So chapter 2 is we're going to continue ways of describing data sets, quantitative data, right? So there are two types of measure of the data set. One is a measuring center. When you measure in center, we're going to use the mean and the median. And then the other type, which is later in the slides, is the measuring of the spread or measuring of the variability. So that we use standard deviation and the quartiles. Okay. So the first slide is just a review here. We already did this in chapter 1, right? So measuring the center, we use either mean, which is average of the value divided by the sample size, or the median, it's just another fancy way of saying the middle values of the data set when you sort it from smallest to largest. All right, so let's try the example here, the French fries example, the ways of the French fries. Before I try this, what do you think I'm gonna do first? By the way, turn on your R if you want. I'm gonna turn on my too. What do you think I'm gonna do first? The first thing first, when I'm given a data set.
Would you order them from least to greatest?
Okay, that's plausible, yes. And then the very first thing, maybe the very first thing, I would do that too. But what else? The very first thing I would do before I even order it. I'm gonna graph it, right? I wanna know what the distribution, I wanna know what's it like, right? I wanna know what's it like. So let me share my screen for the R. All right, so the first thing first, I'm going to graph it. So before that, I'm gonna enter in the data. Now, because I don't want to import data. So I'm gonna create my data here. So I'm gonna call French fry FF, French fry. And then I'm gonna write it as vector. So C in the parentheses. So here I have 78, 72, comma 72, comma 69. Watch me if I got it wrong, okay? Comma 81, comma 63, comma 67, comma 65, comma 75, comma 79, comma 74, comma 71. Oh yeah, comma 83 again, comma 71 again, comma 79, comma 80, and then last, comma 69. All right, so for the short data set, you can do this way. For long data set, import data set would be faster. And then run it, right? Command enter or command return, or just put a cursor somewhere here in that line and then hit run. Let me see what the histogram would look like, right? Oops, should be capital. Histogram of FF. Look like that. Let me make it. It's roughly normal. It's kind of normal to me, right? It looks kind of normal. Maybe I'll do red this time. Right there. It looks kind of normal-ish. So what I'm gonna do next is I'm gonna compute the mean. All right, so compute the mean. Do I have to do by hand? No, I don't want to do by hand. I don't want to do by hand. I'm just gonna do right here. So the mean is in R, just the function is just mean, and then parentheses, and then your data set. Right here, I don't have column. I just have one vector here. So just put in FF, and then it'll run for you. So the mean is 73.5. What is the unit? 73.5 what?
Grams.
Yeah, grams. Very good. Does anyone remember the notation for the sample mean?
The X bar.
Yeah, X bar right there. Thank you very much, X bar. Use R. I'll just write down the slides. I can show you later. And then question 2, he asked for computing the median. So median. Right there, 73. 73 as well. No, does anyone remember the notation for median? Just big M, right? Just big M. I just follow the book. Some other professor use ADA. They use a Greek letter. But I'm just following the book, so just big M. Or you can just say median equals 73 grams. Now, because the data set is roughly normal, so the mean and the median is very close in values. If it like perfectly normal, which is rare in real life, then the mean and the median should be equal, okay? Which we're gonna talk about it too in chapter 3, I believe. Or maybe now, yeah, maybe now. All right, okay, so what I want you to do next is I want you to click on the slide, say click here for French fries data. I want you to click there. Let me get the French fry data out. Google. Well, you know what? Give whatever value you see there, delete it. Okay. It's from yesterday. I forgot again to remove those values. I want to do from scratch. So delete those. I'll delete it. Let me delete it first. Or you can do it yourself if you copy. French fry. I'm going to delete these. So I can show you from scratch. All right, so you guys see the Google Sheet now? Yeah. If you haven't deleted those, delete those. Right. So the mean is just the mean is in Google Sheet. The command is average, so average right there, and then just highlight your data set because it's short. I can highlight it. So the mean is 73.5, like we have, right, and the median the same. Enter equal median. Highlight it. 73. 73. Now, question 3 asks, what if the smallest weight was incorrect? Enter as 3 grams instead of 63 grams. So the next step is, say somebody entering the data wrong. The smallest value here is 63, but before that, I'm going to sort it first. I'm going to sort. Maybe I'll sort. So I'll copy this one, copy over here. And then I'm going to sort. I don't have to do that. I'm just going to sort. Yeah, equal, sort. And then highlight that one. Comma, 1. In ascending order, yes, so true. I'll wait for you a little bit. So equal, sort, highlight the range, comma 1 because the first column. And then the next one is asking you, are you doing ascending order? Then yes, I'm doing smallest to largest, so true. Right there, it's short for you. So now, if someone say they enter, instead of 63, they put 3. They put 3. Okay. So here, if I change this guy into, maybe I'll copy this one. Come on, let me copy. Copy. Right there. I'm going to change this one because I don't want to mess up my original data. 63 here, instead of 63, I'm going to do 3. Do not do it from here because it's going to mess it up because you have a command there. So here, let me calculate the mean again. So mean equal, and I'm going to highlight this range right here, the one that I changed from 63 to 3. Okay. Look at that. The mean is decreasing, right? It's getting smaller. What about the median? Equal, median. Highlight it. Stay the same. The median stay the same. So when I change from 63 to 3, the mean change, but the median stay the same. So what does it tell you? What does it tell you?
The mean is non-resistant.
Good, very good. I like your language. So for outlier, if you have an outlier in the data set, the mean is sensitive to the outlier, right? It's sensitive to the extreme observation. So it's sensitive. Why is it sensitive to the extreme observation? Sensitive. But the median is not sensitive to the extreme observation at all. Sensitive. Why is the mean is sensitive to the extreme observation, but not the median?
Because when you add up all the values, if you have like lower or higher numbers, then that gets played into effect of the average, with the median just the middle number.
Good, right? The median is just the middle number. The outlier or extreme observation is on the two sides, right? So whatever I change on the two sides doesn't matter because all I care is the middle number, right? However, the mean is you taking the average of the data set. So if the data set have a smaller value compared to the original data set, then the numerator is smaller, right? If you have a smaller numerator divided by the same denominator, same n, same sample size, then your result is smaller, and vice versa. Right? All right, remember this page and remember make sure you know how to explain why the mean is sensitive to the outlier and why the median is not. All right.
Sorry, I'm just a little bit confused still on like why it would be sensitive or not.
Oh, the mean is sensitive because how do you compute the mean?
How do I what? Sorry.
How do I compute the mean? The mean. What does mean mean? Mean average, right?
Average, yeah.
Average mean what? You add up all the number in the data set. You add up
and divide by
the
the total.
And divide it by the sample size. Yeah.
Yeah.
If you change one of them, then is your answer changed, right?
Of course.
Yeah. What about the median? Median is just the middle number. So if you change the number in the data set, say change because extreme observation, so it's going to be either on the left tail or the right tail, right? It doesn't affect the middle part.
I got you. Okay. Yeah, that makes sense. So.
Yeah. All right. Does anyone have any more questions? Thank you for asking. All right. So now measuring, we continue doing this. Again, these slides, I already talked about this last lecture, I believe. If the number of observations n is odd, by the way, observation mean data points, same thing. The median m is the center observation in the order list, right? So for example, if I have say 5, 6, 9, 10, 20, just make up some number. So the median will be just what? Just the number 9, right? This is the middle number. If the number of observation is even, then the median is going to be the average of the middle numbers. So say I have the same one, 5, 6, 9, 10, 20. I add one more number here, say 30. Okay. So now instead of five values, I have 6 values here. Okay. So the median is going to be the average of the middle 2. Okay. It's going to be 9 plus 10 divided by 2. Now, do you guys remember this formula that I told you to I told you last lecture as well? If you have if you have a short data set, you can eyeball it, no problem. But sometimes you have a long data set and you have to do it by hand. Then one way that you can locate the median is using this formula, n+1 divided by 2. Yes. So this formula is the location of the median, okay, not the value of the median. So for example, if I have, maybe I should have, I'm sorry. Maybe I should have highlighted in green. I'll highlight in green. So say for this one, I want to locate the median. N is 5 here, right? I have 5 data points. So 5 plus 1, oops, I meant green. 5 plus 1 divided by 2, which is 3. So this is the third place. I mean, it's the third place. 1, 2, 3, right? The third one, that's your median. What about down here? I have even number of data points, 6. So 6 plus 1 divided by 2, which is what, 3.5, right? When you have fraction, when you have things that half and half like this, that means the location of the median is gonna be the integers values that include 3.5. So what numbers that 3.5 is being in the middle gonna be? What?
3 and 4.
Yeah, 3 and 4, right? 3 and 4. So 1, 2, 3, 4, right? So 3 and 4, that's the location of your median. It's helpful when the data set is long and you have to do by hand. If not, you just eyeball it. It's not important. You don't have to know it. Okay. So far, so good. Do we have any question here? All right. All right, so here, we're gonna come back to this, but I'm gonna just say this now. If your curve is symmetric curve, is a symmetric distribution, is perfect, which is rare, very rare in real life, then the mean is gonna be equal to the median. Remember the French fry data set, we have the mean is 73.5, right? Maybe I wrote down here. The mean is 73.5 and then the median is 73, right? And then when I construct it, the histogram is look very, it looks normal, right? Not perfect, but pretty normal. Very, have that bell curve shape. So, so in a perfect sense, if you have a perfect normal curve, then the mean is going to be equal to the median. If it's a right skew curve, is a right skew distribution, then the mean is going to be larger than the median, which is makes sense, right? Because right skew means you have a lot of big value at the right hand side. So when you average it, your result is going to be big, right? Compared to the middle point. And if it left skew, then the mean is going to be less than the median, which is again makes sense. Left skew means you have a lot of little data point, the small data point on the left. So when you average it up, it's smaller than the middle number, which is the median. Okay. So here, X bar, you write it down here, X bar equal median. Here, X bar greater than median, and then X bar less than median. Again, I'll come back to these slides in the next chapter, which is next week. All right, now, one more things about one more measure of a data is mode, which is, if you ask me, it's not important, but I kind of tell you. So at least when you see if in homework, you know what it is. Mode is the set of values, is most frequently occurring values, right? So for example, I just make up this data set. Here is the times that STAT 2220 students spend study per week. Hour, right? So say 4 hours, 3 hours, 7 hours, 4 hours, stuff like that. So what is the most frequently occurring numbers here that you see?
4.
4, thank you, right? So that's your mode, that's it. Mode, 4. In the Google Sheet, I think the command is just mode. And then the range of the data, that's it. This Google sheet. Very simple. All right, next one. So that's the measure of center. Now we come to the measure of the spread, right? Now, if your data is normal, then it's okay. If you give me a mean or the median, it makes sense. But if the data is not normal, if it have like left skew or right skew, or even worse, bimodal, right? Then I want more information than just the median or just the mean, right? Because if it left skew, right skew, there's a lot of things going on. There's a lot of outliers things there that I want to know more about the data set than just give me the average number, right? So here is the income of 10 randomly selected households of a city. Income are in thousands of dollars. So if you see 24, there'll be 24,000, 35,000, 20,000, so on and so forth. I'm gonna plug this data set in R. So if you wanna do like I did before, remember to write it in vector form, C and then parentheses. So here, I say, I'm just gonna put a note for myself. This is income data set. C, plug it in, 24, 35, 20, 59, 65, 74, 46, 20, 250, and 50. Run. And then I wanna graph it. I always do. I wanna graph it. Histogram of income. You're gonna run before you actually. Come on. There you go. There you go. That's the histogram of income. Okay, it's a right skew distribution. Now I want the mean. You can do this on Google Sheet if you feel comfortable. I like R because it's faster. Mean income. All right, so 64.3. I missed something. I think I missed. Oh, it would be 200 here, 200,000 instead of 20. I'm so sorry. So let me do it again. Let me run income again. And then histogram, still right skew. And then mean. Right, mean. All right, the mean is roughly $82,000. If you look at this data set, does it make sense? If you look at this data set, does it make sense? Are you satisfied with the number $82,000 for the average? Say no. Why is that?
Because there's a high population that's like way less than that, but just because of the 200 and
yeah, very good, very good. That's it. Because the majority make less than 82,000, right? It's just because the two guys here make so much, it just kind of alter the average. That's why for right skew or left skew, mean and median doesn't say a lot of things, right? So what we're gonna do next is we're gonna require, tell me what is the minimum, what is the least one of the people in the group make, right? What is the minimum, what is the maximum, what is the quartiles like Q1, 25%, how 25% of the population make how much and stuff like that, right? I need more information so I can draw a picture for myself, right? So this is called the file number summary for R. It's gonna be summary. The function is just summary, and then income. And it'll spit out those values for you. But I'm gonna show you how to do by hand because on the exam, you will do by hand. So let me go back to the slides.
So in the exams, are we allowed to use a calculator?
Yeah, absolutely. You can use calculator. Mhm. All right, so file number summary. I'm gonna teach you how to fill these out. But before that, I'm gonna go through some theory part. Let me charge my iPad is kind of low. Give me 1 second. Okay, maybe when the break, I'll do it. So the file number summary is described the spread of the data. We have range and the interquartile range. So the range is just the measure of the spread over 100% of the data, right? Min, max minus min, that's it. Percentiles, the percentiles denote P to the TH, is the value such that percentage of the observation fall at or below that value. Some common percentiles you're gonna see on the box plots is first quartile, denote Q1. This account for 25 percentile of the data set. Okay, so the data set is 100%. So Q1 will be 25 up to 25% of the data set. Second quantile is 50%, 50 percentile of the data set. What this remind you of?
The median.
Median, right? The median. I'm sure you mean median. It's the median, right? 50-50, right? The median, the middle value. And the third quantile is account for 75 percentile. Interquartile range is the measure of spread over the middle 50%. The formula is, maybe I'll highlight in blue, is Q3 minus Q1. Make sure you remember this, okay? This interquartile. All right, that's it. Let's do this. Let's use the same income data set and we're gonna do by hand. So minimum, maximum, that's easy, right? If you, first of all, I have to sort this first. I gotta sort it first. So 20 minimum, and then 24, 20, 24, what else? 35. And then what else? So 46, yeah, 46. And then 50, and then 59, and then 65, and then 74, and then 200 and 250. Let me move this to the left a little bit. Okay, so min and max is easy. That's min, and that's max. And that's min, that's max. This data set is even, so the median is gonna be the middle two, right? So the median is 1, 2, 3, 4, 5, 6. So 5 and 6. That's your median. Or I'm gonna say Q2, okay? I don't wanna write median. Median is gonna be 50 plus 59 divided by 2. Fifty plus 59 equal, and then divided by 2. 54.5. So roughly $54,000. Now Q1 and Q3. Do you agree that this right here, that line right there, divide my data in half? Yeah. Yeah, right. In half, 5, 5. So 25%, that's half of 50, right? So where's half of 50? Where's half of 50%?
25.
35, right? 35. This value right here. Oh, I'm sorry. That's funny. I'm sorry. I meant the data, the value of the data. Yeah, 25 is correct. 25 half of 50. So in this case, in the data set, that right there is the data values is 35,000, right? So that's my Q1. Okay, it's odd, right? You say 1, 2, 1, 2, 3, 4, 5, right? The 5 values. So the odd one, middle one would be the third one, so 35. And then someone else tell me what's Q3 equal?
74.
Very good, thank you, 74. Let me warn you first. Google Sheet and R, or even different software like Minitab and stuff like that, they use a different algorithm to compute the numbers, five numbers summary. This is called 5 number summary, the mean, max, and Q1, Q2, Q3. So it's gonna be different than doing by hand, and that's okay. Okay, if on the exam I want you to do by hand, then you do what I'm showing to do right now. It's fine. Okay. But if I give you a value already, probably is from the software, then you just relies on that. Okay, it won't affect your exam. Right.
Hey, Professor, can I ask a question?
Mm-hmm.
So I just tried downloading R Studio because I've been using Google Sheets, and there's like an error trying to download it. Was there a specific way that you downloaded it?
I can't help you because I can't see it. Some people tell me that sometimes you have to download R first in order to download R Studio. Is that true?
There's a video you can watch that shows you.
Yeah, I go to the instruction slides. I have the video link in there. Just watch.
Okay, thank you.
Okay. Mm-hmm. All right. So long story short, do by hand is slightly different than to do it by the software, but that's okay. It won't affect you. All right. So let me copy these down here. The mean is 20. Just copy things down. What else? 250. Median is 54.5. Sorry if I
Professor.
Mm-hmm.
I was just wondering, so you're saying for the exams we can't use these programs. What were you saying in the first class then about using R for extra credit on the midterm? What was that about?
We'll talk about it later. I don't want to use lecture time to talk about it, but don't worry. I'll let you know what you need to do. Okay?
Mm-hmm.
Yeah, don't worry. Q1 is 35. Q3 is 24. R is not required for the class, but if you can use it, awesome. I would love to see you use it, but Google Sheet you need to know, and calculator. But I use R a lot, so I want you to understand what I'm doing. Range, the range is what? The max minus the min, right? So 250 minus 20 is 230,000. And then IQR, what's IQR? What's the formula again? Someone else remind me.
Was it Q3 minus Q1?
Yeah, which is 74 minus 35 equal, what is that? 59, 1, 6, so 10 minus 5 is 5, 9. 7 minus 4 is 39. All right. Okay, we're gonna do this in R. We're gonna do this in R here. Go ahead and turn on R, and then please, yeah, you already know how to do that, right? The summary. Then go ahead and click here for the income data. We're gonna go to the Google Sheet again. Delete that value. I forgot to do that for you. Keep forgetting. That was the income data. Let me delete those. Come on, it's so slow. Let me share my screen. There you go. All right. I need to charge my thing. You know, yeah, let's power this through, and then we take a little break. Okay. So the min is just equal min, right? Min there, and then highlight your data set. For the max, same thing, equal max. And highlight your data set. For quartile, is the command is equal quartile. And then highlight the range. And then comma, you tell which one? One, the first one, Q1, so 1. Right? Equal. So it give you 37.75. That's okay. I told you it's going to be a little bit different than do by hand. Even in the book, they have a little note that says so. Okay. And then do the same thing with median. For median, you either use a quartile and then change the 1 into 2, or can equal median. Doesn't matter. Okay. I'm just gonna be lazy and copy here over here and change from number 1 to 2. So that means Q2. Same thing here. Oops. Same thing here. I'm going to change to number 3. So that means Q3. Right there. IQR is Q3 minus Q1. So equal. Q3 is cell F2 minus Q1 is D2. Range is max minus mean. So equal max minus C2, which is min. Let's just all that for you. Sorry, I'm a little fast because I'm gonna. How everyone's doing? I'm gonna pause the recording, the Zoom recording. All right, so for bar class, before we pick the charge type, we need to take care of one thing. So you need to have an income, this words here, on the same lines with the values, with these 5 values, min, Q1, Q2, Q3, and max. Okay, that's just how it is, right? So what I'm gonna do next is I'm gonna highlight this line right here from income all the way to maximum. Okay, so click on that and highlight. And then now insert chart, same thing when you do histogram. Chart type, you go all the way down and go over candlestick chart, candlestick, right there. All right, next I'm gonna show you how to do in R real quick, okay? And then we'll take a break, promise. R. So here I have the data income here already. All I need is bar plots. Box, yeah. Bar plot right there, the function bar plot. And then income, only one vector, so I don't need $sign. Right there, the bar plots. Call maybe green. There you go. Can you guys see it? Yeah, I like the R when I construct a bar class. Why? Because it showed me the outlier. It showed me these 2 outliers. Remember the 200,000 and 250,000, right? For in Google Sheet, it doesn't show me the outlier, so I don't like it much. Okay. All right, take a 5 minutes break, and then when we come back, we'll continue with 2.4. Yeah, we continue with drawing the bar class by hand. Okay. So earlier I just showed you how to do the 5 number summary by hand, and we do in Google Sheet and R, and draw a bar class using R and Google Sheet. Now I want to show you, next I'm going to show you how to construct a bar class by hand. Okay, but before that, there's a slide I need to talk about. Bar class, same thing as histogram or stem plot, is used to display quantitative variable. Okay, specifically bar class used for displaying 5 numbers and 5 number summary. Right? So when you look at the bar class, you will be able to tell the minimum, the maximum, Q1, Q2, and Q3. But you can not do that on the histogram, right? So bar classes have that that perk to it. Now, the only drawback is that backplot does not tell shape. You know how histogram tell you what shape it is, either normal or left skew, right skew, bimodal, etc. Right? But backplot does not tell shape. Okay, remember that. Here is the step how to construct a backplot. I'm gonna go through this with you. If you don't understand, that's fine. But I'm gonna go through it with you. So when I construct a backplot, I go back and explain one step by step. Then hopefully if you hear a second time, it better. Right? So the step is this. First, you're gonna label the axis with the value to cover the minimum and maximum. I'm doing my backplot vertical, so I'm gonna label my y-axis. It has to cover the minimum and maximum. Okay. And then the next step is make a box with the end of the quartile 1 and quartile 3. Okay. The third step is once you have Q1, Q2, Q1, Q3, you can go ahead and draw a line to determine your Q2, which is the median end. Right. After that, you have a box with Q1, Q3, and Q2. Now you're gonna try to spot out the possible outliers. How do I know which one is outlier? Well, there's a rule. There's a rule. The rule is that if you take Q1 minus, let me highlight in green here, take Q1 minus 1.5 times the interquartile range, or Q3 plus 1.5 times the interquartile range. If any values that above or below that range, that's going to be your outliers. Okay, which I'm going to demonstrate with you. Don't worry if you don't understand, kind of lost, that's okay. And then once you have possible outliers, some data set have outliers, some data set don't, especially when it's normal, right? It won't have outliers, which is fine. Right, so step 5 is extend the line from end of the box to the smallest and largest observation that are not possible outlier. All right, let me show you how to construct this. So for example, here is the summary of the French fry data. Right, I'm gonna construct this by hand. So first of all, I'm gonna draw my y-axis and x-axis. Maybe I'll do it in black. Yeah, like that. And then x-axis. Right. Make sure your y-axis, because I'm doing vertical backplot, somebody do horizontal. I'm gonna make sure my y-axis have cover the minimum and maximum. Minimum is what? Minimum is 23, maximum is 83, right? So I'm gonna do a thing here. So at the bottom, it's gonna be 60, and then maybe 65, 70, 75, 80, and 85. That's what cover the minimum and maximum, which is from 63 to 83, right? Second step is, so I'm done with that. Second step is make a box with n at quartile Q1 and Q3. So Q1 is 69, and Q3 is 79. So 69, where is 69? 69 is roughly here. Right, roughly there. That's 69. So this right here, this one is Q1, and Q3 is 79. Oops, so sorry. Roughly here. And so you don't have to do the dash thing and then it's Q3. I just like to do it so I show you which one is Q1 and which one is Q3. And then I'm gonna make a box. Now I can make a box. The box with Q1, Q3. Next step is gonna be the median, right? Step number 3 is gonna be the median. The median is, let's see what median is, 73. 73, maybe here. 73, maybe here. Median, I'll use yellow. Q2, that's my median. Okay. All right, I got a box with Q1, Q2, Q3. The next step is you're gonna learn how to spotting your outlier, your possible outliers using the rule in green right there. Right. So first of all, I need to calculate the IQR. Right. IQR equal, what's IQR is Q3 minus Q1. Q3 is 79, right? Q1 is 69, so 10. IQR is 10. IQR is 10. And then 1.5 times IQR. Remember this, the formula in green. 1.5 times Q. So I'm gonna do one shot. So here I have Q1 minus 1.5. Oh, everything it just died on me. Today I have my 4 classes. Give me a second. Go ahead and do it. Do it yourself. Q1 minus 1.5 times IQR, which is 69 minus 1.5 times 10. And then Q3, same thing with Q3, Q3 plus 1.5 times IQR. So 79 plus 1.5 times 10. All right, so this one equal 69 minus 1.5 times 10, right? 69 minus 15, which is 54. That's the left-hand side of the range. Now, Q3 plus 1.5 times IQR, which is 79. I'm sorry, yeah, this is right, 79 minus 1.5. I'm gonna move it to the left so I can write. 10. 79 minus 15 is 64. I'm sorry, plus, this is plus 84. 79 plus, yeah. Yeah, 1.5 times 10 is 15, 94. Okay, so the range is, I'm gonna call this allowance range, okay, allowance range. I just make it up. Just to distinguish with the data set range, the min and max. So the allowance range is from 54 to 94. Now our data set is the minimum is what, 63, and the maximum is 83, right? So 63 and 83. Is the data set range inside the allowance range?
Yes.
Yeah, so we're good, right? It's not outside, so there's no outliers, right? As long as it's inside that allowance range, there's no outliers, right? So yay, no outlier. So we can skip a step 4. Well, we just did, but we don't have to draw it. Now step 5 is you're gonna draw your maximum and minimum. So max is minimum first. Let's do minimum. Maybe I'll do in red. Minimum is, I forgot, 63. Oh, 63 down here. And then make sure you put the little dot to connect. That's what they meant by extending. And then the maximum. That's your min. And then the maximum is 83. Right, that's it. That's you complete your box plots. Do you have any question?
What if our range was outside of the allowed range?
Very good. If it, hypothetically, if it's outside, no, you don't have to write it down here. If hypothetically, if it's outside, maybe I'll use green here. Say 63 to, I'm gonna add another outlier, say 100, yeah? Then, so 83 and then 100. So 100 will be, you know what, here. Instead of 83, I'm gonna change it into 100. Yeah, I'm gonna change. So no 83. So it's gonna be up to what? So what below 83 is 81? So 80. It's 80. 83 is the largest one, and then what? 80, right? And 80. Okay, so 80 and then 100. No 83, right? So if it's outside, then what you're gonna do is you're gonna make sure your y-axis had to include 100. I'm just gonna do not to the scale, okay? I know I don't have enough space, but this is your outlier right here. You make a little dot there, a little hollow dot or solid dot, whatever dot you want, but make a little dot there that I can see, okay? So that's your outlier, about 100 grams, right? And then the maximum now is no longer 83 because 83 is not there anymore, right? I put 100. So the maximum now is 80. The next largest one is 80. Yeah, 80. So 81. Maximum now is 81. What was it? Yeah, 81. I'm so sorry. Yeah, I didn't see that. So the maximum here now is 81. So your maximum is gonna be right here now. Does that make sense? And no more of these, no more of that.
It does, thank you.
Let me go back to my, all right. Okay. All right, so that's the bar class, how to construct by hand. Right here, that's question, was it Roman asked me earlier? Was it Roman? Here is the modified bar class. What if the largest weight of 83 grams was actually 95 grams, right? So they take out 83 and they put 95 in there. So the maximum here is 81, right now is 81. Well, a maximum is 95, but I'm just gonna say 81. If 95 considered outlier, even though it's the largest number. 95 is the outlier. So IQR is the same, everything the same except for the data range, right? So if you plot it in R like I did here, you're gonna see that 95 outlier is outside the range. The range was what? The black one. The range was from 54 to 94. So 95 is to the right of 94. So, and here, look at that 81, right? 81 is now your maximum. 81 now is your max.
So if we're asked to evaluate the range of a certain data point, we just have to ignore the outliers, right?
Yeah.
Okay.
Yeah.
Is the IQR still 10?
Same, yeah, same. Because IQR is Q3 minus Q. Yeah, IQR is the same, right? We don't change the number of the data points. So Q3 and Q1 stay the same, yeah? Right, we just change at the end. Q3, Q1 is not quite at the end, right? Just the half of the 50% left and right. Kind of like median, remember the median, it doesn't affect by the outliers. This one I would like you to do by hand at home. I'm not doing for you. I already did for you here. You can see here. So your this is the income data. Now, I want you to do it at home using R or Google Sheet. Now you asked me like, Mimi, I don't see the maximum. I should see something like this, right? Something extending out and like that. The reason you don't see it because the scale from 50 to 100 is very tight. So you don't see the value. By the way, this guy is 250 and this guy is 200. Those are outliers, right? And then the next largest value will be what, 74,000, right? So you don't see the 74,000 right there. It's just very tight, right? So maybe somewhere there, but we don't see it. If you make your scale bigger, longer, then you'll be able to see it. All right. Do you have any questions so far before I move on? Okay. Now the side-by-side box plots, that's just single box plots. Now I have single box plot. Now I have two or more. Right? I have multiple box plots. Here's the example, a random sample of 100 parents of grade school children who were recently interviewed regarding the breakfast habit in the family. One question asked was if their children take the time to eat breakfast. So if the children say she eat breakfast, then yes. And then if they don't eat breakfast, then no. Right? So we have two group of people here, right? Children who eat breakfast and children who don't eat breakfast. Also, the grades of the children in some core classes, reading, writing, math, was also recorded, and standardized score on a 10-point scale was computed for each child. So if you look at the side-by-side plot here, we have two populations, children who eat breakfast and children who don't eat breakfast. Also, they want to know, they also record the grades of those children within those two groups. Okay, so it looks like the children who have breakfast perform better, right, in school. They have higher score on average. Anyway, here's some question I want you to answer. Number one, what is approximately the lowest grade score by a child who does have breakfast? The lowest grade score of a child who does have breakfast. Anyone?
Not considering the outlier, it would be 6.
No, the lowest. They didn't say anything about outlier or maximum. The lowest.
5.5.
Yeah, 4.5, right? You meant? Well, okay, which box is who had breakfast? The right one, right? What's the smallest value there?
6.
Say, Ahmad, what do you say?
6.
No, smallest values.
Oh.
4.5.
5, right? The smallest value. They didn't say anything about outliers or minimum. If they ask minimum, then 6, right? But they say the lowest. I'm just going to consider the lowest in the data point, okay? From smallest to largest. The lowest is 4.5. If I want to ask about, if I want you to answer like, if I want you to answer 6, and I will say minimum, okay? 4.5 points. All right, second question. Heads up, it's going to be a little deceiving. So be careful before you answer this. Among the children who did not eat breakfast, so in the box with no box, 25% had a grade score of at least blank points. At least. At least mean greater or equal to, right? So if you look at the,
Is it 4?
Well, first of all, 4 is minimum, right?
I think 7.5.
Very good. Very good. Yay. Who's answered that?
That was me.
Who's me?
No, Randy.
All right, Randy, you got 2-point extra credit on your exam. Remind me, okay? I'm gonna put a note here.
I will definitely remind.
Randy. Very good. Very good. Randy R. Yeah, it's 7.5. Why is it 7.5, Randy?
Out of all the data points, if we're looking from the top 25% is going to be at least 7.5.
Yeah, because the word at least, right? Because 25% at least had the score is 7.5. That's 7.5. Well, the number of children who have the score that at least 7.5 grade score is the 25% above, right? Not 25% below. So this question is kind of deceiving, right? Because it say 25%. So a lot of students will choose this like 5.5. Like, oh, Mimi, that's 25%. That's Q1, right? But you're gonna be careful because the word at least change everything. Right? If I want to say at most will be Q1 will be 5.5. Right? Okay, very good. Can you do something like this on the exam? You're gonna have something like this on the exam. All right, last one. Consider the following statement. The symmetry in the backclass for the children who not eating breakfast imply that the distribution of the grade scores of such students is bell-shaped. What do you think?
False.
Why? Yeah, it's
Because the box plots don't decide the shape.
Yay, thank you, Medicine. 1 point for you. 1 point for which Medicine, what's your last name?
Goul, G-O-U-L.
Yeah, Medicine G. I'll put down here so I don't forget. Medicine. Okay, all right. Yeah, false because backclass does not tell shape. Only histogram or stand plot. And later quartile plot. But I don't think I'm teaching you that. I'm not sure. We'll see. Maybe I do. I think I do. All right. 2 point. The question, the mid-size cars. Click on that data. Click on that data, and I want you to fill in the minimum, Q1, median, Q3, and max on your own. You're gonna do on the Google sheet. Let's go ahead and do it, okay? I'll catch up with you. Mid-car. Mid-car, did I? If you see anything value in there, delete it for me, okay? Apologize, I don't think so. But... Is there? Yeah, is there? Delete it for me, please. I apologize. Delete that one. All right, let me go over this one real quick, and then we'll take we have a quiz. So you guys know how to do minimum, Q1, Q2, stuff like that, right? Those are easy. IQR, the same thing. IQR, which is Q3 minus Q1, right? Here, okay, so we fill in the box, so good. And then it's draw a box class of these data. So go ahead and draw that. Number 2, draw a box class. You guys remember how to draw that? Remember, I have to have this something over here, some letters, some words over here, and the best one, it will be the name of the column that you want to do the box plot. So MPG, sorry, MPG, my program, and then highlight that from MPG to maximum, insert, charge. And one candlestick right there. Okay. Now, one thing about the Google Sheet box class, they don't show me the outlier, which I don't like. All right, next question. What is the shape of the distribution shown by the box class? Well, I don't know. It's not histogram, right? Which feature of the box class led you to this conclusion? Okay, before I can answer that question, I need to, now, if there is no outlier, then your data distribution consider what? If there's no outlier, if there's no outlier, so, and assume that you have some kind of variation, but if there's no outlier, what you can assume, at least what you can assume from the first plan about your data distribution.
That the median and mean are the same. So
Which is?
So it's normal.
Yeah, it's normal, right? It's somewhat normal. That's the first thing we assume. Assume that their variation, you know, data values are different, not the same. So we have a rectangle box. It's normal. So in order to spot the outliers, I already show you how to do this by hand, right? So we're gonna do it by Google Sheet. Same formula, just instead of writing, just click in some boxes. So here Q1 minus 1.5 times IQR. Q1, so equal, and click on the Q1 cell, 23 minus 1.5. You actually have to type it in. Times is the star, which is the number 8 with the star on top of the number 8. So shift 8 star. IQR, click on the IQR cell, 7, right there. Your IQR is 12.5. I'm sorry, the lower range is 12.5. The lower allowance range is 12.5. And then the upper one, I'm lazy. I'm just gonna copy this. Oh, D3 is Q3 30 and then plus. So the allowance range is from 12.5 to 40.5. Now, I wanna know if there's any outlier. So what I'm gonna do is I'm gonna count equal, remember count if right here. And then the range, I'm gonna tell you the range, it's gonna be a long data set, is go from A2 to A190, is a long one. A2 colon A190, I don't wanna highlight it, it's just too long. So I take a look at it and then I see that it's from A2 to A190, and they'll highlight it for you when you do it like this, okay? Count if quotation. I want to know if it less than 12 point. Is there any data point that less than 12.5? Okay. Then colon again. Close parenthesis. There's one value that less than 12.5. Well, if you eyeball it, 12 right here, less than 12.5, right? And what about is there any value that bigger than 40.5? So same thing. I'm gonna be lazy and copy this command, just change up a little bit. Now I want to know if it's greater than 40.5. There are 17 data points. There are 17 values that are bigger than 40.5. Okay, so you see outlier, yeah? You say that, okay, there's outlier. What do you think? What kind of distribution this data set have?
Maybe a right skew.
Yay, right skew, right? Thank you, Rami. It's right skew because you have a lot of the number that bigger than 40.5. It's a lot of big data. Right skew. So yeah, so that's the that's how you answer question number 2. Okay, we're gonna finish 2.7 next time. Now I gonna let you do the quiz. Let me